Hi friends, welcome you all to Vetrii Engineering Academy. In today's lecture, we are going to discuss about the capillarity, which is one of the important topic in fluid properties under a fluid mechanics subject. So friends, many times in many competitive examinations like GATE examination or Indian Engineering Service examination or Tnpsc examinations, frequently questions are coming from this topic. So thorough understanding of this topic is very important in order to score good marks. So now let us see and discuss in detail about capillarity, right? Friends, I think some of you may be thinking that capillarity is due to cohesion, and some of you may be thinking that capillarity is due to adhesion. So the answer for this is capillarity is due to both cohesion as well as adhesion. So once we say that capillarity is due to both cohesion as well as the adhesion, now we need to understand what is cohesion, what is adhesion. So cohesion and adhesion, so we have cohesion and adhesion. So in order to understand what is cohesion and what is adhesion, we need to understand about molecular attraction. So what is molecular attraction? Students, molecular attraction in universe, we know each and every molecule is surrounded by many molecules. Yes or no? So the attraction between these molecules is called as molecular attraction. Based on studies, this molecular attraction is proportional to m1 m2 by d square, where m1 and m2 are the mass of the molecules and d is the distance between the molecules, right? So when mass of the molecule increases, when mass of the molecules increases, the molecular attraction increases. At the same time, if the distance between the molecules increases, what will happen to molecular attraction? The distance between the molecules increases, molecular attraction decreases. Yes or no? So this is what is molecular attraction. Now what we are talking is capillarity is due to cohesion and adhesion. So now we know what is molecular attraction, then we need to think what is cohesion. So cohesion is nothing but molecular attraction or attraction between the molecules of same type or same substance. So the molecular attraction between same type of molecules is called as cohesion, and the attraction between molecules of two different substances or two different types is called as adhesion, right? Now we have seen what is cohesion and what is adhesion. Yes or no? And now we are telling that capillarity is due to both cohesion as well as adhesion. Now we have to discuss in detail about how it happens. So in order to explain this concept, right, in order to explain the capillarity concept, here I have taken a diagram, right? In case 1, here I can able to divide this into two. One is, this is case 1, this is case 2. So in order to explain this, in one vessel, in case 1 I have taken water in a vessel, in case 2 I have taken mercury in the vessel, right? So here I have mentioned mw is nothing but mass of water molecule, mg is nothing but mass of glass molecule, and ma is nothing but mass of air molecule. So based on the mass, we know that the mass of glass molecule is higher than mass of water molecule is higher than mass of air molecule. Yes or no? Yes or no? Now keeping this in mind, let us correlate this to the molecular attraction, the formula, and then we will try to discuss what are all the various forces that exist at the interface. Now we can able to see. So here in this vessel we have water below, above this we have air. Yes or no? Below we have water, above we have air, that is nothing but the interface. At the interface, what are all the various forces that existing? So if you are able to see, so here we have the water, the molecular attraction, that means the cohesion or cohesive force between water molecule, that we can able to see. And also here we have air, so the cohesion or cohesive force between air molecules. Yes or no? Then we have water and glass, that means adhesion or adhesive force between water and glass. We have air and glass, adhesion or adhesive force between air and glass. Yes or no? Adhesion and adhesive force between water and air. Yes or no? Among these forces, we are able to see which force will be higher. So which force will be higher? As per the definition, the adhesion or adhesive force between water and glass is higher. Yes or no? As this force is high, that means water and glass, the adhesion force is high. Try to listen carefully. As this force is high, all the water molecules which are present at the interface, which are already under tension, all the water molecules which are already under tension, as this adhesive force is high, all these molecules will be attracted towards the glass wall. Yes or no? All the water molecules at the surface will be attracted towards the glass wall, resulting in a rise at the line of contact of water with the glass. Yes or no? So if I try to insert a narrow glass tube in a vessel containing water, what will happen? If I try to insert a narrow glass tube in a vessel containing water, what will happen? Water will rise in the tube. Yes or no? Water will rise in the tube. What is happening here? So if you are able to see here, the vertical component of surface tension, this vertical component of surface tension force can have or can able to lift up equivalent weight of water. Yes or no? The vertical component of surface tension can able to lift up equivalent weight of water to reach its equilibrium. Yes or no? So because of that, water has been raised in the tube. This we call as capillary rise. So here in this case, why capillarity is occurring? It is because of adhesion or adhesive force between water and glass. So capillary rise is occurring because of adhesion. Correct? Now we have seen this has been corrected. Capillarity is due to adhesion. Then coming to the second case. So here I have taken a mercury in the vessel. So all of we know mass of mercury molecule. See, MM represents mass of mercury molecule, Mg is mass of glass molecule, and Ma is mass of air molecule. So we know mass of mercury is higher than mass of glass is higher than mass of air. Yes or no? And also if you are able to see at the interface what are all the various forces that exist, as already we have discussed, we can able to see here the cohesion or cohesive force between mercury molecules, cohesion or cohesive force between air molecules, and then the adhesion or adhesive force between mercury and air. We have adhesion or adhesive force between mercury and glass, adhesion or adhesive force between air and glass. Yes or no? Among these forces, which force will be higher? As mass of mercury molecule is high, compared to other molecules, the cohesion or cohesive force among the mercury molecules is high. Yes or no? So as this cohesion or cohesive force is high, all the mercury molecules will be, as this force is high, all the mercury molecules will be repelled from the glass wall. Yes or no? All the mercury molecules will be repelled from the glass wall, resulting in a fall at the line of contact of mercury with the glass. Yes or no? Resulting in a fall at the line of contact of mercury with the glass. Yes or no? Supposing that if I insert a narrow glass tube in a vessel containing mercury, what will happen? If I insert a narrow glass tube, mercury level will fall. This is the original level. Yes or no? Here we have. So mercury level will fall in the tube. So this is because, so this vertical component of surface tension can have, or it can able to push down equivalent weight of mercury to reach its equilibrium. Right? So, this is happening because the cohesion among the mercury molecules. So, this we call as capillary fall. So, here capillarity, again capillary fall is occurring because of cohesion between mercury molecules. So, now in general we can able to say, in one case capillarity is happening, capillary rise is occurring because of adhesion between water and glass. The other case capillary fall is occurring because of cohesion between mercury molecules, and in general we can able to say capillarity is due to both cohesion as well as adhesion. Yes or no? So, mathematically, so this can be written as, supposing that if I wanted to write this in mathematical form, so how we can write? Say this one. So, this total surface tension force, that is vertical component of total surface tension, vertical component of total surface tension force must be equal to weight of liquid lifted up or pushed down. Weight of liquid lifted up or pushed down, yes or no? In one case liquid has been lifted up, the other case liquid has been pushed down, yes or no? So, what is this vertical component of total surface tension? So, this is nothing but surface tension into acting along the circumference pi d and over a angle of contact theta. So, this surface tension force acting along the circumference with angle of contact theta can be written as sigma into pi d into cos theta. This must be equal to weight of liquid lifted up or pushed down. Weight of liquid we can able to write this as volume of liquid into specific weight. Yes or no? So, this volume is nothing but area into height into specific weight is gamma, correct? So, area is nothing but pi by 4 d square, if d is the diameter of the pipe, if d is the diameter of the glass tube. So, this will become into h into gamma, left hand side we have pi sigma pi d cos theta. So, this and this will go cancel. So, what is left out? We need the value of h, yes or no? The value of h is equal to, we have 4 sigma cos theta by gamma d, correct? Gamma also can be written as rho g, this we know, or 4 sigma cos theta by rho z d. So, this is what is the capillarity, general equation for capillarity, right? So, based on the value of theta, if the value of theta is less than 90 degrees, theta is less than 90 degrees, what will happen to cos theta? Cos theta must be greater than 0, yes or no? So, positive values. So, once cos theta is greater than 0, h is positive, represents capillary, what is this? Capillary rise. H is positive, it is nothing but capillary rise, yes or no? Supposing that theta is greater than 90 degrees, what will happen to cos theta? Cos theta value will become negative, that is cos theta is less than 0. This implies h is negative, which represents capillary fall, yes or no? Capillary fall. So, what is that you have to keep in mind as far as capillarity is concerned? So capillarity is due to both cohesion as well as adhesion. And also the important expression for capillarity in general, H is equal to 4 sigma cos theta by gamma d. Based on the value of theta, we can able to take this as capillary rise or capillary fall. Yes or no? So let us try to solve few problems. Previous asked questions in various competitive examinations. Let us try to solve. Okay. Yes. Yes, see this one. So this is the question asked in GATE examination. The question asked in GATE examination. Yeah, GATE 2012. What is that they have given? The capillary rise of water. The capillary rise of water in a 1 mm diameter glass tube. In a 1 mm diameter glass tube is approximately what? What is the answer? Is the value of H they are asking. What is H? They are asking. What is the data they have given? So they have given the value of D. They have given the value of D as 1 mm. This is nothing but 0.001 meter. Correct? And then the value of surface tension they have given as 0.075 Newton per meter. This is what is the data they have given. They are asking for H. What is the expression for H? H is equal to 4 sigma cos theta by gamma d. Yes or no? This is what is the expression we have. Correct? So in this expression, let us see what are all the data already available here. We are able to see here. So we have the value of surface tension, and then they have given the value of D. Correct? So what is this one? Gamma. So the liquid they have given is nothing but water. Liquid they have given is nothing but water. So gamma water is nothing but 9810 Newton per meter cube. Correct? Correct? So what is unknown here? Unknown is theta. So whenever they have not given any angle of contact, okay, so in case of water, if we use in a glass tube, clean glass tube, so the angle of contact varies between theta is equal to 0 degrees to 10 degrees. This we can able to take it as assumption. So based on studies, so once it is 0, that means cos theta or cos 0 is nothing but 1. Yes or no? Cos 0, correct? Cos 0 degrees is 1 and cos 10 degrees is approximately 0.98. Yes or no? So in this place, in this value of cos theta, we can able to take approximately 1. Yes or no? So if we take this assumption, we can able to calculate the value of H is equal to 4 sigma is nothing but 0.075 into cos theta is 1 divided by 9810 into the value of D 0.001. If you are able to calculate this, you may get, so what may be the answer? You may get approximately 0.0306 meters. Yes or no? So what is that they have asked? They have given in terms of mm. That means, so this is nothing but H is equal to 30.6 mm. That is approximately in the answer 30 mm. So your answer for this is this one, 30 mm. So answer for this is nothing but right answer for this is 30 mm. Right, very simple, direct substitution. The value, only thing is, so whenever they have not given the data for angle of contact, this assumption we can able to take. Correct? Right. Next problem. Yes, see this one. This is GATE 2016 question. So in a capillary tube experiment, water rises to a height of 5 centimeters. Water rises to a height of 5 centimeters. If the diameter of the tube is reduced to half, please try to understand. What is that they are asking? Reduced to half of its original value, the height of the water column will be. So this problem is related to capillarity, once we are able to see. So capillarity, the expression we have, H is equal to 4 sigma cos theta by gamma d, right? So this value in this problem they have given only one value. What is the value they have given? They have given the value of H directly. How much? 5 centimeters. Height they have given as 5 centimeters. That means this entire value they have given as 5 centimeters. Yes or no? By giving this, what is that they are asking? If the diameter of the tube is reduced to half of its original value, that means this value, this d, what is that they are doing? They are reducing this to half. So in place of d, we need to substitute half d or 0.5. That's all. What will happen? So this is equal to 4 sigma cos theta by gamma into what is this? Here we have to substitute d by 2. So what is this one? This is nothing but 2 into, so 4 sigma cos theta by gamma d. So what is this? 4 sigma cos theta by gamma d, already how much they have given? 5 centimeters. This is 2 into 5, that is 10 centimeters. What is the answer? What is the answer? It's nothing but C. Very simple. Without calculating anything, just if you are able to recollect the relationship, H is equal to 4 sigma cos theta by gamma d. In place of d, we have to substitute d by 2. We will get the answer. That's all. Very, very simple. Only thing is you have to remember the formula. That's all. Right. Next. Yes, what is this? So read this is TNPSC, okay. The question asked in TNPSC, okay. In a capillary experiment, the surface tension of the liquid is increased. Surface tension of the liquid is increased with all other parameters remaining constant. What will be the effect on the height of liquid rise? Very simple. So direct expression again, H is equal to 4 sigma cos theta by gamma d. What they say? What they say? All other parameters constant. Only what is that they are telling that increase is nothing but surface tension. Surface tension of the liquid is increased. So what is that here we have? So height, that is H is, what is the relationship we have? H is proportional to sigma, all other constants, all other parameters constant. Once sigma increases, what will happen to H? Increase, that's all. Once sigma increases, H increases. Why? Because all other parameters constant. So what is the answer here? What is the answer we have? See the options. The height will, first option itself, height will increase. So height will decrease, this is wrong. The height will remain unchanged, is wrong. The height will first increase then decrease, wrong. As H is linearly proportional to the surface tension, the height will increase. Correct, very simple. So this is asked in 2020 TNPSC, right? So next one. Next problem or next question. Yes, TNPSC 2012 question. Let us see. What is that they have asked? Water in a clean glass capillary tube of radius What is that they have given? Radius 0.5 mm. Rises due to capillarity. Is capillary rise. Assuming the surface tension of water is 0.072 Newton meter. Okay. The density of water is, they have given 1000 kg per meter cube, and contact angle is nearly 0. That means just now we have discussed contact angle theta is 0, means cos theta value will become 1 approximately. So that's it. Here also they have given that one. The capillary rise is given by the capillary rise is given by the expression. So here they have given capillary rise H is equal to 2T cos theta by rho z r. Don't confuse. Okay. So this is r. So earlier what is that we have written in our expression? So this is H is equal to 4 sigma cos theta by gamma d. This is what we have written, same thing. So the value of d is nothing but r by 2. Okay, or 2r. D is nothing but 2r. So this 2 and 2 will go cancel. This is 2, and this value of sigma they have mentioned with t, that's all. And this is nothing but rho z. Just they have rearranged. That's all. Yes or no? Just they have rearranged. So in this expression, now let us see what are the values they have given. So they have given the value of surface tension, correct? And also they have given the value of cos theta approximately equal to 1. They have given the value of rho, z value we know, r value, they have direct substitution, nothing is there. Simple direct substitution. Let us substitute. So this is equal to 2 into the value of surface tension 0.072 into 1, cos theta is 1, divided by rho is nothing but 1000 they have given, z is nothing but 9.81 into the value of r 0.5 mm, that is 0.0005 meters. If we substitute all the values, I think what may be the answer you get? 0 point approximately, yeah, 0.0294. This is in terms of meters. They have given in the problem in terms of centimeters. Okay, so this I can able to write as 2.94 centimeters. Yes or no? The value of H is 2.94 centimeters. Now check. So which answer is correct? Approximately 3 centimeters. So this is approximately 3 centimeters. What is the correct answer? What is the correct answer? B is equal to 3 centimeters. Very simple. Direct substitution. Very, very simple. Yes or no? Yeah. Okay. Next one. Yeah, so we have completed. Yes, see this one. See TNPSC 2018 question. TNPSC 2018 question. What is that they are asking here? See this one. Capillary rise in a glass tube is caused by the interaction of adhesive and coercive forces. Which statement best describes their roles? Let us see one by one. So last one what they have given? The capillary rise is independent of both adhesive as well as coercive forces. Wrong. Why? Because already we have discussed capillarity is due to both cohesion as well as adhesion. So here capillary rise is independent. No, capillary rise is dependent on adhesion. Yes or no? Capillary rise is occurring because of adhesion between the water and glass. So this is wrong. This is wrong. Correct. Next one. Both adhesive and coercive forces oppose the capillary rise. Capillary rise is supported because of adhesion. Capillary rise is supported because of adhesion. So this is also wrong. Cohesive forces pull the liquid upward. Cohesive forces pull the liquid upward. Whether it is correct? What cohesive forces do? In case of mercury, cohesive forces will try to repel. That means mercury molecules are repelled and it has been taken downwards. It's completely wrong. Cohesive forces pull the liquid upwards is wrong. Cohesive forces push down the liquid. Okay. And adhesive forces have no significant effect. Adhesive forces are having effect. Why? Because it supports the rise. So this is also wrong. Then adhesive forces between the liquid and the tube wall pull the liquid upward. Yes, adhesive forces will be water and glass. As the attraction forces, that means the adhesive force is high, all the liquid molecules are attracted. That's why it has been pulled upward. This is right. While the cohesive forces keep the liquid molecules together, because of togetherness only, entire liquid is moving as a continuum. Yes or no? So this is correct. So what is the right option here? What is the right option is nothing but A. Very simple. This is how we have to analyze the question. Each and every word we have to read and understand, then only we have to give the answer. Okay. Next. Okay. Okay, next problem. What is GATE 2012? Yes. In a capillary tube of radius r, the liquid rises to a height h. If the surface tension of the liquid is sigma and the density is rho, then the correct relationship, nothing is there. Direct, if you are able to recollect the relationship, directly give the answer. What is the relationship? H is equal to 4 sigma cos theta by gamma d. So here they are mentioning about the density. If we wanted to write the expression in density, so this can be written as, this is equal to 4 sigma cos theta by gamma is nothing but rho z, and in terms of r radius is nothing but into 2r. Diameter can be written as 2r. Gamma can be written as rho g. Now see the relationship. What is that they have given? So H is equal to, so they are asking H is proportional to sigma r. H is proportional to sigma by r. Sigma we have in the numerator. In the numerator we have sigma, denominator we have r. Correct or no? This is correct. Okay. Then second one, B is equal to, H is proportional to sigma by rho r. Sigma by rho r. H is proportional to sigma. In numerator we have correct, denominator we have rho, denominator we have r. The entire equation, let us see. The entire equation. This is, let us see one by one. Finally we will conclude. So H is proportional to sigma by rho r. Then H is proportional to sigma by rho r square. Here is, we have only r, no r square. So this may be wrong. And last one you see, H is proportional to sigma by rho square r. Rho square r. Here we have only single, not square. So this is wrong. Now let us see these two. What is that they have given? So in the expression, H is equal to, we have sigma, we have rho, we have r. So in this expression they have missed rho. So this is, so ultimately we get sigma, H is proportional to sigma by r. So this is how we have to analyze. So initially, as H is proportional to sigma r, but rho is missing here. We have to analyze all the 4 options and then finally we have to conclude. So the correct option for this is H is proportional to sigma by rho r. Correct? Okay. Next. Okay, right. So this is about the capillarity. I think I have understood the capillarity very, very clearly. We have seen what is the concept of capillarity. So we have seen that capillarity is due to both cohesion as well as adhesion, and also we have seen the relationship, most important relationship, H is equal to 4 sigma cos theta by gamma d, and based on the value of theta, we have seen what is capillary rise and what is capillary fall, and also we have try to solve few problems which have asked in GATE examination as well as Tnpsc examination. So it's very, very important topic. So you have to practice many number of problems so that you can able to do the problems in a correct way in competitive examinations, right? So again we will see in the next lecture, we will try to take some other topic. Okay, so I'll stop here. All the very best. Thank you.